Hello everyone, we are a group of students from UTEM, Faculty of Manufacturing Engineering FKP, and today we are going to present our group project for Bmfp 3122 Manufacturing Sustainability. The product that we have chosen for our group project is the Mr. Potato Chip Bag Packaging. Our group consists of me, myself, LIEW, Chayuki, Fatin Fatihah, and Lee Kim Long.
Hi, my name is Fatin Fatihah and I will present to you project overview. The project analyzes Mr. Potato Packaging's life cycles. The goal is to assess the environmental implications of packaging's raw material extraction, manufacturing, distribution, usage and disposal. The research will also investigate sustainable Mr. Potato packaging options. This may include testing biodegradable or recyclable material, creative packaging, and recycling or composting programs. Other than that, the project aim is to encourage sustainable practice, reduce environmental consequences, and help Mr. Potato switch to a circular and resource-efficient packaging system. Mr. Potato background. Mr. Potato is a well-known brand in the snack industry, specializing in the production of potato chips. The brands offer a wide range of potato chips flavor and has gained popularity among consumers worldwide. Mr. Potato also striving to minimize its environmental footprints through sustainable packaging practice. What about its history? Mr. Potato was created in 1992 by Mami Double Decker Malaysia Berhad. It is a result from the audience couldn't get enough of the snacks. So as the result, Datuk Pang Chin Hin started to grow from instant noodle snack to snack sector. Next, I will present about the objective of this project. First of all, the objective of this project is to quantify the environmental implications of packaging's raw material extraction, production, distribution, and disposal. Secondly, is to consider material selections, production, transportation, and waste management to improve packaging's environmental performance. Thirdly, to create sustainable packaging design, material and management decision by explaining the packaging environmental impact. Fourth, recommend alternate material, energy efficient manufacture, waste reduction and enhanced end-of-life management to lessen packaging environmental impact. And lastly, to encourage sustainable packaging design, productions and disposal through raising the awareness.
For the literature review, they are divided into three aspects. First is the environmental, second is the social, and third is the economical. For the environmental aspect, non-biodegradable material used in potato chip packaging contribute to environmental pollution and excessive plastic waste. To address this issue, there is potential in using biodegradable material like virgin polylactic acid for eco-friendly potato chip packaging. Next is implementing sustainable packaging practices in both waste prevention, recycling and composting, and it is essential to integrate functional and innovative material into packaging design. For the social aspect, potato chip packaging has social implications on consumer behavior and societal concern through design, aesthetic and labeling. By incorporating proper disposal instruction, packaging can also encourage responsible waste management practices. Lastly, for the economical aspect, sustainable packaging offers economical opportunity to meet demand of eco-friendly products, reduce plastic waste, and enter the growing sustainable market. By using biodegradable material and green packaging options, businesses can lower costs and improve the processability.
For now, I will proceed to the analysis of the old packaging. As we all know, the Mr. Potato packaging is made up of a few layers, namely PP on the inner layer, LDPE film in the middle, as well as an outer layer of PE. Next, for the mechanism, it is first started by a meticulous material selection. Then, during extrusion, solidified polymer materials are passed through a die to create a continuous packaging film. After this, the film may be printed with necessary information. Additionally, multiple layers of the films will be laminated using heat and pressure so that it forms a composite structure. Lastly, the potato chip bags, which is filled with the potato chips, will be sealed by using the heat seal technology. As for the function of each part, the PP inner layer serves as the barrier against moisture and air to preserve the freshness of the chip. Next, for the LDP intermediate layer, additional strength and flexibility are added to the potato chip bag, and this acts as a protective shield against physical damages. Furthermore, for the PE outer layer, it provides a smooth and visually appealing appearance for the packaging. For organic solvents, it is used for the application of vibrant colors to print information. Lastly, for EVA copolymer, it ensures the bag is securely sealed due to its strong adhesive properties. Last but not least, the first weakness of the product is its low durability, since most of them are tinned, which are more prone to physical damages. Similarly, the barrier properties of the bag may not be optimal since it will still cause moisture absorption and flavor loss over time. Also, complex design may lead to a slower production rate. In addition, fluctuating prices of raw materials or inefficiencies in material usage can affect the profit. Finally, conventional potato chip bag packaging often has limited recyclability or composability due to the multiple layers of different materials used. This slide is showing the bill of materials for the bag packaging of Mr. Potato Chips, and it is created by using OpenLCA. As we can see here, the transport via lorry mode is added under the input, and this will add up to an amount of 138 kg for the input. In order to ensure that the input value equals to the output value, the output bag packaging is set to be 20 kg, while all the flows will generate about 138 kg of plastic packaging waste. The following slide is showing the product system created through OpenLCA, and it consists of 10 processes and 12 connections. The highest in-degree process is the potato chip bag packaging, which receives 6 inputs from other processes, while the highest out-degree process is the extrusion plastic production film, serving as an input for 3 other processes. Now, for the product life cycle of Mr. Potato Chip bag packaging, firstly, it is the extraction of crude oil and then refining it into naphtha, which is a key material for plastic production. Then, the plastic films, for example the LDPE, PE, and PP, as well as EVA copolymer adhesive, along with organic solvents for printing, are processed and manufactured. Next, the production phase includes extrusion processes to create plastic filaments and the use of EVA copolymer for heat sealing, as well as the organic solvents for printing labels on the bag packaging. In the use phase, the potato chips are packaged and transported to the retail locations for sale. Finally, in the waste treatment phase, the bags are usually disposed through landfilling or incinerated. After understanding the product life cycle of the Mr. Potato bag packaging, an end-of-life analysis is carried out. First of all, in terms of recyclability, the bag packaging is hard to be recycled due to its complex structure. In terms of reusability, it is only possible if the materials used are durable and washable. In terms of the ability to be repaired, it will be challenging to repair the flexible plastic films or foil-based materials. In terms of remanufacturing, it is not possible due to the low cost and single use of the Mr. Potato bag packaging. Lastly, for disassembling, it will be difficult to disassemble due to the multi-layer structures contributing to the packaging of the Mr. Potato chip bag. Now, for the environmental properties of the material selected generated by the OpenLCA, we will look into 5 impact categories, namely the water consumption, fine particulate matter formation, freshwater and marine ecotoxicity respectively, as well as global warming. The top 5 contributions to the environmental impacts are from flows like market for polyethylene, market for polypropylene, extrusion production, market for EVA copolymer, and organic solvent production. The major contributions to impacts such as water consumption, freshwater, as well as marine ecotoxicity will be the extrusion production of plastic film. This is because this process is a water-intensive nature process since it requires a lot of water for cooling, cleaning, and lubrication. Not to forget that the plastic resins used and the chemical additives used will result in water pollution and ecotoxicity. Next, for fine particulate matter formation and global warming, though it shows that LDPE contribute the most to both of them, but it generally does not directly contribute significantly to the environmental impacts. It is possible that in open LCA, the environmental impacts coming from the LDPE production are considered, including the indirect emissions associated with energy consumptions or emissions from upstream processes. And this can significantly influence the calculation of the environmental impact in open LCA. Now, for the materials like PP, organic solvents, and EVA copolymer, since it typically involves the use of fossil fuels, hence it will result in greenhouse gas emission contributing to global warming. Also, their manufacturing processes and emissions can potentially contribute to the fine particulate matter formation. As for water consumption, it is associated with their production processes. And lastly, the improper waste management for these three materials can lead to freshwater and marine ecotoxicity. Now, for the labeling standard and regulations of the Mr. Potato Chip bag packaging, the first standard that should be included will be ISO 186, which is the labeling of consumer goods. In this ISO, it emphasizes the use of symbols and pictograms to convey information effectively. Next, ISO 10462 should also be included, which is the guidelines for developing product standards for consumer packaging. In this ISO, it emphasizes on ingredient list, nutritional facts, storage instructions, as well as allergen warnings, as you can see on the picture at the left-hand side. Lastly, the ISO 21067 should also be included, which is the Consumer Product Information CPI that emphasizes on structuring the information in logical and organized manner by using a plain and concise language as well as avoiding technical jargon. Usually, visual aids can also be used under this ISO to enhance the instructions for the consumers, as you can see at the picture on the right hand side. Moving on to the energy efficiency of the Mr. Potato Chip bag packaging, from the Sankey diagram shown, we can see that majority of the contribution to the energy flow is from the LDPE and PE packaging film, which are both obtained from the market of polyethylene and extrusion production for LDPE packaging film. It is then followed by PP packaging film, which is obtained from the market for polypropylene. In addition, the market of EVA copolymer, LIEW, and solvent production will also contribute some energy for the bag packaging of the potato chips. The system is said not to be energy efficient since the energy is only focused on a particular area of flow in the diagram.
So we introduced the new snack packaging design. In this new packaging design, we are using compostable substance material that are made from renewable resource like plant-based polymer or bioplastic. This substance is a great option for ecological packaging, since they can be decomposed into organic when exposed to the environment. Besides that, the new packaging are less metal and lighter. We have optimized the dimension and thickness of the packaging to minimize the material usage. So, reduce the material also will help to lower the transportation emission. In addition, we are also using the eco-friendly printing method and chemical-free vegetable ink when printing the packaging design. By doing this, we can ensure the packaging is safe to compost without releasing toxic into the soil. So for the new material design, we are using this material. So in the outer layer, we are using cellular frame. This cellular frame are biodegradable, are compostable. They are created from the plant-based cellular source such as cotton or wood. This cellulose also provides the excellent barrier property that can guarantee the protection and flash of a chip. Next, for the ink and dye, we are using the bio-based. These bio-based ink and dye are derived from the renewable resource, such as plant-based source. These ink have smaller carbon footprint. Besides that, they are also free from harmful chemicals. For the next layer, we are using the metallized cellulose film. The cellulose film are combined with a thin layer of the metal coating in metallized. The metal coating are often defend against the moisture, oxygen, and light, but the cellulose string are offered the strength and barrier quality. So next, for the final layer are using the bio-based PO/PLA. These PO/PLA films are made from the bio-based polylactic acid, and the compostable polymer are generated from renewable resources like corn flour or sugarcane. So for the adhesive level, we are using the water-based starch. These water-based starch adhesive are eco-friendly alternative for the solvent-based adhesive. They are much less harmful to the environment because they are made from natural starch sources such as corn or potato. Now we are seeing the comparison between old packaging and new packaging design. For the old packaging, they usually use PP, LDPE, and PE as their material. These kind of material are not biodegradable or compostable since they are made from the fossil fuel. But at new packaging, they are usually use the compostable film material, including the metallized cellulose film, bio-based PO/PLA film, and cellulose film. These materials are completely biodegradable or compostable since they are made from the renewable resource. For the environment impact, since the old packaging are used this kind of material, they will continue contribute to the plastic waste and will cause the pollution and harm to the ecosystem. But at new packaging, the plastic issue was addressed as they are used the fully biodegradable and compostable material in the design. At printing ink and adhesive, the old packaging are used the organic solvent. This organic solvent will detrimental to both human health and the environment. While in new packaging, we are using the wire-based ink and water-based starch adhesive. These are since they are made from the renewable resource, this bio ink and dye and adhesive are environment safe and will not reduce the hazardous waste. So for the DFP analysis, we are seeing 5 impact categories. The first is fine particulate matter formation and pollution. The second is global warming impact. Third is freshwater ecology. And the fourth is marine ecotoxicity. And the fifth is ozone formation, human healthy. So in these 5 impact categories, we can see that the new packaging design is much better for the environment compared to the old packaging design. And now we are seeing the life cycle assessment for the new package design. So in the first stage, the low material extraction. This stage of the raw material are prepared. The environment impact at this stage can be influenced by the sustainability of certain material, including the renewability and extraction technique. And the second stage of manufacturing and production. At this stage, the raw material are converted into the final packaging product. The environmental effect of manufacturing may be influenced by the energy use, pollution, and waste production. Since the new package design are used the bio-based material and water-based adhesive, and there may be and reduce the environmental footprint. So the next stage is distribution and transportation. The new packaging is transported across the long distance from manufacturing site to distribution center. The long distance can contribute to greenhouse gas emission, so the efficient logistics and transportation practice can minimize the environmental impact. So the fourth step is use and consumption. At this stage, the food waste and related greenhouse emission can be decreased if the package is made to maximize the food preservation by prolonging shelf life or preventing damage. The last stage is end of life management. When coming to end of life of the new packaging, is an advantage of in biodegradable property. So we can recycling or composting the new package. This can help in the environment without polluting the ecosystem.
And last but not least, conclusions. During this assessment, we learned that Mr. Potato packaging has several environmental impact and prioritize potato chip sustainability. LCA, or also known as Life Cycles Assessment, helps to make sustainable package design, material, and management decisions. Mitigations and best practice can help the industry to become more sustainable. The LCA project has promoted ethical practice and new solution for Mr. Potato packaging's environmental impact. Other than that, the industry may collaborate to design more sustainable packagings that meets environmental, consumer, and long-term sustainability goals. And last but not least, the packaging LCA projects promote sustainable potato chips productions and informed decision making. That's all from us. Thank you for watching and thank you for listening.